Hard or soft, it all gets turned into usable wood the same way. Transforming round logs into square boards was once a backbreaking two-person job. But in 1813, a Massachusetts woman named Tabitha Babbitt noticed that half of the back-and-forth motion of a two-man saw was wasted. So she designed a circular saw that revolutionized the lumber industry by cutting wood in a single, more efficient motion.
When a saw blade hits a piece of wood, it cuts right through these cells. It mashes them out, just rips right through them like a freight train.
Logs between 8 and 16 feet enter the line, and to ensure maximum yield, laser scanners map each cut.
Got the two lasers, and they line up with two saws that move in and out. So once he lines it up, he feeds it through, and when it comes out the other end, you've got a square edge, nice square board.
Make that log make money, because you can make money by using that log right.
Because every piece of wood is valuable, the laser-guided cutting ensures a minimum of leftovers. But it turns out even those have value. All the wood scrapes and sawdust are sold to companies that press it into boards or burn it as fuel.
We waste nothing. In today's world and the market, with timber values where they're at, we can't afford to waste anything.
So what about the cellulose? It's the lignin that gives wood its great strength. But what about the rest of it? All that white stuff that makes up most of the inside of a tree? That's cellulose. And while it may not be as strong as lignin, it does have a surprising ability. It's incredibly flexible. One of the ways we take advantage of cellulose is in paper. In fact, paper pretty much is flattened tree guts. The invention of paper goes back thousands of years. The Egyptians had a version called papyrus, made from a reed of the same name. But true paper, paper made from processed cellulose, dates back to 200 AD China, where it was first used as a wrapper, long before it was used for writing. And the basic way of making paper, boiling wood chips until the cellulose breaks down, pressing the goo into sheets and drying, has remained pretty much unchanged. There has been one breakthrough though: recycling.
So it's just a constant, endless cycle.
Paper fiber, tree fiber, is extremely resilient. The cellulose can be used in multiple fashions over and over again.
That's because paper pulp is wood that's transformed into a wet mush called a slurry. All of the wood strength is still there, only it's flattened, mashed, and rolled into the indispensable material we call paper. Pulp for making paper comes from both wood chips and recycled paper. The process is virtually the same either way. It just takes more energy and enzymes to break wood chips down into pulp. The process starts with bales arriving at Rock 10's pulp mill.
These are our corrugated bales. They weigh about 1,200 pounds. They're the old boxes that come out of grocery stores, department stores.
To turn these old paper products into new ones, the bales must first stew in a cauldron called the hydropulper. This reduces them from a solid into a slurry.
Huge blender. I mean, 14 feet across, 12 feet deep. Huge motor on the bottom of this thing. It's a huge blender. It's just a lot of power and a huge piece of equipment.
The pulp breaks down within just 10 minutes. Then screens lift all the waste larger than 9/1000th of an inch.
Dirt, tape, sticks, all this stuff that you would see on curbside. He'll clean that out and reject it.
With the mix now purified, the excess water is drained, leaving nothing but saturated cellulose pulp. The outer wall of a cellulose particle is smooth. This makes it difficult for the particles to join. So during the refining process, tiny cell parts or fiber in the pulp must become abrasive in order to form bonds tight enough for making paper.
fiber's like a string. You'll take that string and make it hairy. And then when it gets hairy, that makes it'll bond together again.
That's what happens here. Rollers compress the wet slurry between two bands of industrial fabric. As this slurry sandwich moves down the line, the rollers squeeze out the water, leaving just the bonded cellulose fibers. These bonds hold together single sheets of paper stretching over an assembly line that's 1,300 feet long.
As the screen on the paper machine picks up the paperboard slurry, the water is able to seep through. It's basically a filtering process. And the fiber stays on top of the cylinder, and then as water continually is squeezed out through pressing action until you get to the dryer section. At that point, then energy is added to the paper to basically boil off any excess water.
This happens in the dryer can. It's like one giant hairdryer used to wick any remaining moisture out of the paper.
Dryer can surface is around 220 up to 300 degrees on the dry end. We gradually dry the paper as it goes through the process. A little over 100 dryers on each machine. Pretty much like cooking a steak, you just gradually cook it until it's done. Comes out the other end about 4% moisture.
Now spools literally reel in single sheets of paper, stretching the length of 40 football fields.
It'll be rolled up, and those rolls will weigh about 10,000 pounds.
That's a lot of paper, and a lot of trees and energy saved.
Recycling 1 ton of paper, you actually save approximately 17 trees. You don't use approximately 380 gallons of oil, and you save 4,000 kilowatts of power and 3 cubic yards of landfill space.